things. Now, our next speaker is actually going to take us down a different direction. He's going to take us into the world of open source software and the security vulnerabilities and problems that can be found in open source software. So as they get ready, I'm going to tell you a little bit about our next speaker. His name is Rotem Bar, and Rotem is a very cool cat. Yeah, join me right here, Rotem. Let's give him a hand. You've got a fan, yeah!
Oh.
Cheers.
No. Cheers.
Na zdarovia.
L'chaim, l'chaim.
L'chaim, kampai, as they say in Japan. And Rotem is a very cool cat with more than a decade of experience in cybersecurity and all kinds of things, from penetration testing to vulnerability analysis. And today is going to take us through this rabbit hole of open source software. And one of the fun things that Rotem has done is actually take a year to travel around the world while doing bug bounty programs, which I absolutely love. The stage is yours, Rotem. Let's give it up for him.
Hey. So it's great to be here and be talking in live. Last time I was talking in a conference, it was virtual in my room. And it's so fun to see all the feedback and everybody over here. So thank you for coming. Yeah. So I'll be talking about hacking the open source software. So I started like a year ago or 2 years ago playing with different stuff and found myself every time going into open source, and I will explain different clicker. Oh, okay. The clicker is, yeah. So I will start explaining a bit about who am I, why I do what I do, how I hack stuff. This is super secret knowledge that I will share with everybody, or not so secret. I will tell you 2 stories, one about a traversal attack that we did together with Danny Robinson, he's from AppsFlyer, and and another one that I did in playing with SSRFs just by mistake. So I'll start a bit about myself. So I'm a cyber paladin. This is who I am in the last couple of years. I work in a super cool startup. It's a new startup, half a year old. I created a bug bounty IL meetup, so everybody that wants to join. We had the first event last like 2-3 weeks ago, and it was amazing, lots of good feedback, and I'm sure there will be much more events soon. And I'm a father for a 7-year-old girl. I passed the COVID year with her, so it's it was tough but interesting, and bonded us together, and this is me. I'll get to the point, and the point is how I hack stuff. So this is a bit about my super secret sauce and what I do. But actually, when I see a system, any system at all, I start playing with it. And I'm saying playing, it's not like testing it or checking it out. It's a game. It's a game. I want to start playing, start to see all the stuff over in the system. And when I play with it, then I start understanding more and more stuff over there. But then sometimes something doesn't feel right. And this is a main point in all pen testing and hacking and what we do, is we have these feelings. And I want to, in the next slide, I will talk about what is this feeling and how I get there. But before the feeling, after I felt something is wrong, then I need to understand exactly to the bit level what's happening, why is it happening, and why the developer did this mistake in order to get me more to be able to hack the system. Clicker, yeah. So a bit about what is this feeling. And this feeling is, first of all, is prediction. I have lots of experience playing with lots of different systems, and I expect them to work in a specific way. So when I access the home directory of a website, it needs to give me a 200 OK. When I access something that doesn't exist, it needs to give me a 404. I have these feelings, and then if something doesn't happen like I predicted, like I get into a URL and gives me a 500 error or something else, this triggers my feeling, my spider sense that I want to go and dig deep into it. The other areas I've seen that. Every time I play with a system, and then sometimes I see a PHP or other areas. I'm not against PHP, but PHP is a very good sign or that there may be something wrong over here. But other technologies, I've looked in the way, and I see, okay, this is something I know. It happens. This will probably lead to these areas. And then there's the what the fuck moment that this doesn't need to happen. I'm accessing a URL, and sometimes in new environments, there's different types of responses. I access one time it's one response, the other time it's another response. These are the most interesting areas because you see there's inconsistency of the system, and let's play with that. So I'll start a bit with my stories and what I'm doing. And this is access to one of to a normal system, and I always try to get to something that doesn't exist. And I got from over here response, a 404 response, that there's a server named Cowboy, and gave me it doesn't happen. And this is okay. This is the proper way of what should happen. But then a bit playing with fuzzing and playing with it, and trying to traverse, to do path traversal, we got this answer. And this answer is interesting. I've actually seen it in different areas, but I see also the server over here, it's not a Cowboy anymore, it's AWS ELB. So why is ELB sending me responses to something else? Because I asked the server, I didn't ask the ELB. So I figure out there's a ALB or ELB in the middle, and it is giving me a bad request. But in this specific case, it's something that I knew, and I saw that I did have a traversal injection. I knew it because I saw it in the source code, but nothing, it didn't happen. It wasn't, I wasn't able to exploit it because ELB did something. And this is something is very interesting to understand what is this something. So I added different slashes, start playing, and then adding multiple slashes in front of the URL gave me an OK from the original server. And I'm looking like, why? Why did I add multiple slashes in the beginning and it worked, and when I didn't add them, it didn't work? Like, there's something very weird happening over here, and I need to understand it. So I know this message over here, and I saw this message over here, the bad request with the BG color equals white, and I started looking for it and looking for more instances that give me who is giving me this answer. And I know this is ELB, but I'm starting the investigation. I'm starting to understand why is this happening, how can I hack this, or how can I go to my goal. So the first thing is, let me GitHub this for you, because most people go to Google, I go to GitHub. GitHub has lots of information, lots of stuff. There's code. I can see source code that is happening over there, and I saw lots of different references to NGINX. So we have NGINX, and NGINX gives me the same response, but this is ALB. So is this NGINX? Maybe ALB is using some kind of customized NGINX in the background. So I tried to go more further, and I saw that in the Git commits, because you have all the commit history, and you can look in the comments, then you see there was a BG color, and they removed it. But you can see in the code that it is NGINX, and like this specific page is probably NGINX. So I was looking into the NGINX documentation, and I saw a very nice configuration file, the configuration option that has merge slashes. And merge slashes it actually creates all the slashes and takes them together. So if you put in slashes, like wherever there are multiple slashes, it merges them together. And this can be why multiple slashes made the mistake of passing it through. So I want to understand it deeply. I want to understand exactly what's happening. I have the code. I have everything. But first of all, I want to show about how I'm working. So this was until now black box testing. I didn't have access to the code. I didn't have access to nothing. But I'm good at black box testing. I like to have access to everything I need. So I need access to the source code. I need access to run the programs. I need access to even talk with the developers. And this is why I love open source. It's so easy to go and find the Slack of the open source community or some other forum and just talk with the guys, asking, why did you do this? Why did you do that? Yeah, I can see the code. I can compile it. It's not black box. It's not like a frustrating black box that I don't have anything, and I need to have hours of debugging and fuzzing and understanding what they do. So this is, in the past, I did lots of black box testing, and now today I'm doing more white box and understanding exactly, because it's easier. It's easier. It's beneficial for my clients. It's beneficial for me. It's just, I like it. So I went to the source code, and I found the HTTP parsing area of how it's parsing the URL. So NGINX is parsing the URL in a specific way, and I downloaded this line of code, and I actually created a small program that simulates what I want to do. And I sent /./hello world to it, and I see exactly, I put in debugging comments so I can see what it's doing. And I saw that it's okay. It's not okay, it's actually returning 11, and 11 is a problem with the state machine that it's crashing in some place. And then if I add the multiple slashes, then I can see it's looking for a character slash, it's merging them, and then it's going okay. So the number of slashes needs to be more than the amount of directory traversals over here. And this is what I found from digging into the source code and seeing everything over here. So this is happening in NGINX, and I want to continue. And this is a bit what happened. Then when there's a merge slashes off in the NGINX, it can NGINX can by mistake protect you from traversal attacks, and you just need to add slashes in the front. So I talked with Amazon about this, and I talked with NGINX about it. Both told me this is intended behavior, this is what's supposed to happen. We try to discuss different areas. This ALB is not a protection mechanism, but you should know as a pen tester that it sometimes does protect you by mistake, but there's a very easy bypass to bypass this behavior. Because everybody uses ALB, or not everybody, but lots of companies use ALB, they can't change it. They're not able to change this behavior. And also talking with NGINX, we looked up about the RFC of the HTTP request itself and how you should parse HTTP, and they said, yeah, it's not in the RFC. It doesn't say what you should explicitly do. This is not a mistake. This is maybe a feature request, but we don't want to do nothing with it. It will break lots of stuff. So we decided not to do nothing, but just know about it. But then, if it blocks you, you can add a slash to it. And this is my conclusions from this small research. I have here a blog. You can go into it in NGINX Traversal. It's something I did with Danny. We looked at different payloads, and you can just read about all the investigation over them. So we wrote a blog about this. The blog was blowing up on Twitter. We had even people from, I don't know which, like Persia or other, Yahid Namini talked about it, and people in Bug Bounty used this vulnerability to earn money from this vulnerability. Open Security gave it. Even Stock talked about it a bit. Stock is a very well-known Bug Bounty leader. So this is different references from this blog and what we did. So a bit about this. This was a very fun experiment, but I want to talk also about a different area, a different open source attack that we did. And this attack was actually started by the most boring pen test in the world. And I took a job, and I had a pen test, and I went with all my passion to go and start hacking into the system. And then they tell me the system is just like a lot of different open source programs that are connected together. So we have this open source load balancer, let's say ELB or ALB, I will say, our open source indexer. In this case, it was Elastic. There's a database. There's an open source CMS. There's an open source, lots of different open source services, and all created in a mesh, so they give a solution to a specific client. And then the mission was, you have X hours to find something interesting. And I'm saying, okay, what can I find interesting? So my options was, at first, like the most basic is find configuration problems. This is easy. It's just like going through all the places, looking at the configuration, saying, yeah, this doesn't have SSL, this doesn't have this recommendation. We have different types of problems, and just telling them. But it's not a fun pen test. It's not like something that's fun for me to do. I can go infrastructure, go nmap, and start finding different vulnerabilities. But also, I did a bit about this with Kubernetes because it's fun. But then I had much more hours to play with, and I wanted to find some blood, and I wanted to look more. So finding a vulnerability inside one of these open source programs. So I played with the system. As I said before, I'm playing with the different systems, and I found a hint. What's this hint? I saw over here in Elastic, there's a alerting model. And actually, this is Elastic, but it's not Elastic, because this is an Open Distro plugin for Elastic. And I will get to it, why it's important that it's not Elastic. But then I see this webhook, and this is gives me my spider sense. If there's a webhook, probably there will be an OSS vulnerability over here. So I just went in, put in the default service cluster of registry of Kubernetes. If there's Kubernetes over here, this will exploit. If you have also AWS metadata APIs, this is also a way, localhost 127.0.0.1. There are different ways to start understanding if there's a local SSRF over here, or just go to your server outside. So I put it up, sent a request, and great success. I was able to send a payload. The most interesting area here is it's not only a payload, I can control the whole body of the payload. I can create a post payload, and I can create I see the response back inside my browser when I'm sending it, because I'm testing it, and it sends me back the response. So I can really start communicating with internal services. I can ask the Kubernetes API over here. In this specific case, also the Kubernetes API wasn't configured properly, and I was able to take over the whole pod environment, the node, this specific Kubernetes node, by creating a privileged pod, and then escalating my privileges to have more, to have access to the whole node. But this is not the story. The question over here that I ask myself is, who is responsible? So I know the client has all these open source environments, and he just put it over there. And it's not like he can do something about it. He can add maybe protections, add firewall rules, know that, make sure to isolate the environment, and this is also stuff that I told him. But then maybe someone else is also responsible over here. So we had Elastic. Elastic, it's the Elastic, the framework itself, but it's not theirs. The problem was inside the Open Distro plugin. And there's the Open Distro that they developed the plugin, and maybe it's them. They already did a fork, and they forked the whole distro. And there's lots of talks about why and how, of the GPL, with the AGPL and LGPL, and all these problems with the licensing. But then the question is, who is responsible? So I started talking with Open Distro, and I went actually to search on why this happens, or to ask them. And I asked a I went to the GitHub Open Distro for Elasticsearching and to understand who should I submit to. And over there, it says if you find a vulnerability, tell AWS, because this is AWS responsibility. So it's interesting. This is an open source project, but AWS is in charge of it. So I said, okay, let's send a message to AWS. I send a message to AWS, and AWS tells me, no, this is not our responsibility. Try checking the open distro. So I'm in a loop here. Now I'm, okay, I will go to the open distro again. So instead of going into the loop and trying to understand, I just told them, it says that I should contact you, check with other people, or do whatever you need to understand if this is your responsibility. And then they started talking with me, and I got a hold of the security team, and we had a Zoom. We had multiple conversations about exactly how to solve it and what is the problem. They added update that you can create new, you can create blocks for the servers that are allowed or disallowed to access. So it kind of helps with the mitigation. But then I also told them, but I want to tell the client. So we created a process of getting this a CVE, and we created a CVE on Open Distro for Elasticsearch. We got in the CVSS 3 7.1, and CVSS 2 actually it's less, so this is why I put only the 7.1. I like the high. But then we have, if you want, you can see in my blog over here about exactly what happened and how we handled it. And this is more about the CVE and how it happened. I think this is all about this area. I had much more to say, but we had a time limit of 25 minutes, and I think we're over there. So thank you very much. And if you want, you can come talk to me, and we can talk about later stuff.
Any questions? Any questions, anybody?
No.
All right.